Today we will do a practical of the determination of a diameter of a spherical bob using a Vernier calipers. So first of all, the construction of a Vernier calipers. As we can see in the figure that in case of a Vernier in the construction of a Vernier calipers, there are two upper jaws which are used for measuring the inner dimension or the inner diameter. There are two lower jaws which are used for measuring the outer dimension. As we can see in the construction, there is a vernier scale associated with a main scale. There is a screw clamp by which we can move the vernier scale as per our need. After that, there is a stem for measuring the depths. For doing the practical, first of all we have to know about whether the Vernier calipers will have any zero error or not. To do that, we have to know the classifications of the zero error. First of all, move the two jaws. As you can see, the jaws are denoted with J1 and J2. With the help of the screw clamp, move the vernier scale, move the jaws to touch J1 and J2. In that position, see whether the zero of the main scale will coincide perfectly with the zero of the vernier scale or not. If this happens, then your Vernier calipers will have no zero error, as you can see from the first picture. But if the zero of the main scale is in the left side of the zero of the vernier scale, then the Vernier calipers will have a positive zero error. But if the zero of the main scale is on the right side of the zero of the vernier scale, then the Vernier calipers will have a negative error or negative zero error. Second thing you have to know about the least count. What is least count? The least count of an instrument is the smallest measurement that can be taken accurately with it. In case of a vernier scale, or in case if we want to determine what is the least count of a vernier scale, in case of or it is can be written as vernier constant also. So the formula for determining the least count will be smallest division of main scale divided by total number of division of vernier scale. The smallest division of the main scale will be 1 millimeter, whereas if the Vernier calipers has a total 10 marks, then the total number of divisions of the vernier scale will be 10 millimeter. So the result will become 0.10 millimeter. Now let us determine the diameter of a spherical bob using a Vernier calipers. Put the sphere inside these two lower jaws. In this case, you have to know two things. First of all, as you previously determined what is the least count of this vernier scale and whether the Vernier calipers will have any zero error or not. So now you have to determine two things. Number one, which mark the Vernier zero coincides, or we can see the Vernier zero coincides with which mark on the main scale. This will give you the main scale reading. Along with it, you have to know which mark of the vernier will perfectly coincides with any mark on the main scale. Again, I am repeating two things. The main scale reading will be the Vernier zero coincides with which mark on the main scale will give you the main scale reading, and you have to know which mark on the vernier scale will perfectly coincides with any mark on the main scale. This will give you the vernier scale reading. After knowing all of this, like pen scale reading and Vernier scale reading, you have to determine the diameter of a sphere. How can you do that? First of all, know if the Vernier calipers will have any zero error or not. For positive zero error, you have to subtract the zero error from the reading that you are getting. But as in case of negative zero error, you have to add up the zero error with the reading that you got. So in the table, as you can see, there is a first of all, there is a column named as serial number. After that, the main scale reading, which is in centimeter. After that, the Vernier coincidence means the Vernier mark that perfectly coincides with any mark on the main scale. After doing that, you have to multiply the number of mark with the Vernier constant or the least count, and this will be as the Vernier scale reading or Vernier scale division. After getting the main scale reading and Vernier scale reading, you just have to add these two values, that is the main scale reading plus the Vernier scale reading. But if the Vernier calipers has the positive zero error, then you have to subtract the value of the positive zero error with the reading that you got. For in case of positive zero error, you have to know which mark on the Vernier that is perfectly coinciding with any mark on the main scale, and just multiply it with the least count of this Vernier. So after getting 5 or 6 sets of data, you have to take the mean or average, and after doing that you will be able to get the diameter of the given spherical bob, and by dividing the result with 2 you will be able to get the result, that is what is the radius of the given spherical bob. So this is all about the practical. Thank you all. I hope you all have understood. Thank you.